Hey guys, welcome back. I wanted to talk a little bit about the discussions that we're going to be doing. So, just so you know, this is the first semester that we've done these discussions. So, there may be some bumps in this road, and I hope that that doesn't go horribly, but that will be taken into account when we do any grading that goes along with this. So, a couple of things that I wanted to talk about. I have gotten a question already about how do I find my group. So I'm going to take you into D2L so that I can show you where this comes up. Now, if you click into the discussion information, you will see that there is a topic called group specific discussions. And it should be that when you click in here, the only one that you'll see one for listed as one, how is lab equipment used? One for two, how much sodium bicarbonate is in the mixture, and one for three, what's in the bottles. Now, if you see more than one group here, please let me know because I need to figure out how we deal with that so that we make sure that you're posting in the right group. Okay, so there is that available to you. But that's a discussion that you should see only for your particular group. Okay. Sorry, I was checking something. Not important. So that's how you should be able to find who's in your group. Now, what are the discussions that we're going to be talking about? Well, there are actually four of them that you're going to have to do. So one of them is the introduction, your self-introduction. So I just want you to come in here and give us some information. So a couple of things that I want to know about you: your full name, whatever name you prefer to be called, your major or area of interest. Why do you have to take this class? And not be and I don't want the answer because somebody said so. What are you studying and why is this important to that path of study? Okay, why does it matter? Because helping to give it context should help you be somewhat more invested in what you're doing in theory. Okay, and then your word. So you get to define yourself with one word. That's what you get to give us to let us know something about. Um, I, as I mentioned here, my word is stubborn. I can occasionally get stuck on things, and when I get stuck on stuff, don't always see that I need to let it go. So it's perfectly fine to tell me, hey, well, you're being stubborn. Stop. It's fine. I'm perfectly okay with that. But that is a warning to you guys because I know I can get pedantic about a few things. So there is that. Okay, so I'd like to have you guys introduce yourselves to all of us. In addition to that, there are these laboratory discussions. And there is going to be a post about this that's going to go up in just a couple of minutes with the discussion information. This will show you the link to how is lab equipment used, how much sodium bicarbonate is in the mixture, and what's in the bottles. Okay. Each discussion has specific instructions on what is required for it. There are a couple of components. So in your group discussion, you're going to have to do, each student will have to do 2 posts there. Your group will have to decide what are you going to present as your proposal to the proposal thread, because all posts to the proposal thread should be one per group. Okay, so here's your proposal, i.e., if you were to go into the laboratory to try and investigate this question that you've been given, how would you do it? And the reason that I need that is because I need to be able to talk to you about, is this have you thought about this? Have you thought about that kind of stuff? And then once I have a proposal from you, it is my intention to go into the laboratory and do these experiments for you guys so that you can see what that would look like if somebody did it. Now, I understand that it may look a little different because I'm doing it than if you were doing it, because I know how to use some of this glassware, and so that's going to be a factor in some of what we're dealing with. Okay, I understand that, but I hope that you're being able to view me doing that experiment will give you some information about what's going on and what you might expect from these things. So, based on the scientific method, I would expect that you would have a hypothesis going into this based on the information that you've been given to read, and that we can then form an opinion about how we can go and test it. I can test it, provide you with that data, and then you can look at that data and say, okay, either this supports the hypothesis that I had, or it doesn't, and here's the direction that I should go from here. Okay. Now, when we talk about what it is you're going to be looking at, I'm going to pull up the lab equipment one so you can see what kind of information you've been given. Okay. So you're given an introduction. When planning a given experiment, equipment and techniques used to collect data should offer approximately the same precision. The overall precision of an experiment is determined by the least precise of the measurements you make. Therefore, if you use a piece of equipment that is known to be imprecise, you should not waste time by making other measurements more precisely. Suppose the supplier of the equipment in your instructional laboratory is recently contracted for your team's services to test the volumetric precision and accuracy of items they have supplied. The equipment includes burettes, pipettes, volumetric flasks, graduated cylinders, graduated beakers, medicine droppers, and other equipment as directed by your instructor. I have nothing to add to that, so that's what you're going to be testing. The manufacturing equipment for each lab item is of unknown quality, so the measurement ability of these devices is suspect. Assuming that the balance in your lab has been recently calibrated, which it has, is the only piece of equipment you can trust. So you have some goals: determine the proper procedure for weighing equipment and chemicals, determine proper procedure to measure out specific volumes of liquids, determine the measurement precision and accuracy of the items sent by the customer, and compare the number of significant figures in values measured with different techniques. Here are some materials that you have available. Please understand that if you think of something else that you want to use for this, you can propose that that be used. If we have it available, I will make it available to you and do the experiment using that. If we don't have it available, I'll tell you, I'm sorry, we don't have that available. Some things are not available to us because of the budget that we have. So it then says, getting started. In this investigation, your group has to develop a procedure to determine the precision and accuracy of various volumetric equipment. Because the only item in the lab that you can trust is the balance, your procedure will have to involve a relationship between mass and volume. Hence, the density of water as it varies with temperature can be found here, and the lab is 72.32 degrees Fahrenheit. Okay, so if you open this here, there's a density of water table that you will have available to you. This is something, so if we're looking at 0.2 degrees, this is the value you would use right here. Okay, 1.5 is right here, etc. Okay, so those are the values that you would use for density at those particular temperatures. And of course, this is listed in grams per milliliter versus temperature in degrees C. So remember, we'll have to deal with that because the temperature you've been given is not in degrees C. So make sure that you do a conversion. Okay. As you develop your procedure, keep in mind that you must test both the precision and accuracy of the volume measuring equipment as directed by your instructor. So one of the things that you're going to have to do when you do this is define precision and accuracy. Both of those terms are defined in one of the lectures that I give. They're also in your textbook. Okay, you can Google things as well. It's an excellent resource, although be careful what you choose from Google. Some things are good, some things are bad. I'll let you read out the rest of this, but there are specific things that you're asked to do in this particular one, because this is one of the first laboratories that would have been done from this lab book. And these are actually all taken from a lab book. They're taken from this lab book right here, which I used as a graduate student to teach my undergraduates. Okay, I really didn't think that this was going to be a viable way to do it, but the amount of learning that my students had because of doing it this way was astronomically better than what I would expect. So I'm a big proponent of doing things in this way. Okay, so all of the things that you've been asked to do are here. You need to give me some way in your proposal that you think we should handle all of these. Now, let me give you the caveat. I may ask you questions and say, do you think this is good for this? Have you thought about this? But as long as it is safe to do this experiment, I'm going to let you do it. Okay, so I will go in the lab and I will do it as long as it is safe. It may not give you the answers that you're looking for. And I know that people get upset about that. But one of the things that going into the laboratory is about is learning what works and what doesn't. And if you've never seen something that didn't work, you don't necessarily know what to do with that when it happens. Okay. So I will allow students to do things that are not going to provide them with the data that they need. And that's where this, if your data doesn't support the hypothesis that you put out there or doesn't give you the results that you needed to be able to do this, how would you change it? Because this is something that we come across in working with materials. Okay, if we're doing an experiment to test something, it may not always be designed correctly the first time, and knowing how to deal with that is an important part of this. The other thing that I will tell you is if you didn't do it right, chances are you're going to remember this a lot more. And I know that sucks, but knowing that you made a mistake, understanding where that mistake was, tends to stick things in your brain. And I know it sucks, but it is one of the best ways to learn. So you will be allowed to do things that are not the right thing, as it were. There are also multiple ways to do this. So just because you've made one proposal doesn't mean that there isn't another proposal that would work. Okay, that's another factor that we have to be able to work with. Okay? So I think that's everything I have about the discussion. So again, my thought here is that once I have a proposal from you guys, I will go and collect this data and provide it back to you within 2 days. That's the goal. All right. If something comes up and I cannot do that, for instance, there are no labs on Friday, so I can't go into the lab Friday, Saturday, or Sunday because there's no one else in the building, and that's a safety issue. I can't be in the building by myself. So as long as I have it such that I can work with it, i.e., it's not Thursday that I get it in, at ridiculous o'clock, then I will make sure that you have data come to you as soon as I possibly can. Okay. And again, my plan at this point is to record myself doing this. You may not see everything. It's just me, so I won't be able to move the camera around a ton while I'm doing the experiments. But I'll do my best to make sure that you can see what you need to see, and I will provide you with the data that I collect. Okay. So you will get physical copies of, you'll get electronic copies of the data that I took when I did this experiment. So if you have any questions, comments, problems about anything that goes on with these labs, please let me know. And you have been given a group. Those groups were auto-assigned by the system. I was not involved in deciding where you went. Okay. So if you have any problems figuring out who's in your group, let me know. Otherwise, I will talk to you guys soon. All right. Good luck, guys. Thanks.